Down. Let me welcome our own Willie Payne. He holds a degree in computer science and music composition in Boulder. He is a PhD candidate in music technology at NYU. Across his human-computer interaction research, he uses participatory methods to co-design and deploy creative technologies with community partners. He has published at highly selected venues and has been honored by multiple Best Paper Awards, including the Best Paper Award at Web for All and honorable mention at PHI. During his studies, he has co-taught undergraduate creative learning design course, led an applied research course for undergraduate engineers, and co-taught course to high school students with his research partner, the Fil and STEM programs.
Thank you. So my talk today is called Inclusive Design for Arts and Computing Education. Is this good on Zoom? For the Zoom folks? Cool. So I'm Willie. I use he, him pronouns. Thanks for that intro, Ashutosh. I'm currently a PhD candidate in music technology at NYU, and I'm a CU alum. I went here a number of years ago, and I love it here. I was thinking of using photos of me at CU and on the slide, but I thought it would be a little tacky, so I picked something a little more recent. I'm also an accessible music technology fellow at the Fil or FMDG Music School, which is a community music school in New York City that works with blind and visually impaired students of all skill levels and ages. And I'll say kind of a lot more throughout this talk about my relationship with the school, but they're my research partner, and I also teach and perform with students. And in the photo on the right, I'm sitting with a middle school student right before a concert when he's about to slay on drum set. And I just play melodica, which is kind of janky instrument with him. So I'm next going to unpack my title. What do I mean by inclusive design? Inclusive design essentially means to design with a specific user or user group rather than an imagined general population, which can have the effect of resulting in something that doesn't work for anyone. As Ashutosh mentioned, I use participatory methods. I form long partnerships with users and community organizations, and I include them in all aspects of a design process, from formulation, design, deployment, and evaluation. And finally, to address user need, I build systems that address mismatch between what the user can do and what a technology affords. And I primarily work in creative learning environments. There's a wide need for inclusive education that incorporates arts and computing. Right, there's a widely known achievement gap in computing, in part caused by a lack of learning materials and structures that are accessible, relevant, and engaging to diverse populations. And across my work in the photo on the top and the bottom, I work with specific groups like blind children and Black and Latina girls who are underrepresented in STEM. Additionally, art pushes design and engineering forward. It's not enough for a musical system to just be usable. It must be expressive. It must operate under rigorous conditions like strict timing. It must have a low barrier to entry, but a high skill ceiling, right? Like if you touch a piano, you can play some pretty notes at the start, but you can learn the piano for years and years and years and years and still have more to grow. And finally, educational arts and learning environments are great for evaluating human-computer interactions. They're real world and messy, offering a lot of conditions to test intervention. There's built-in time for participants to learn and use a new design. And in my experience, there's also potential for high engagement because people like being creative and they like making music and art. So I've done inclusive research in a wide range of arts, computing, and educational settings. I've worked with blind and visually impaired or BVI people with motor impairments, and as mentioned, underrepresented roles in STEM. And I've published in a wide range of places like CHI, Assets, which is computers and accessibility, transactions on computing education, and new interfaces for musical expression, which has a conference submission due date on Tuesday. So I'm going to be working on that all weekend. And today I mainly focus on the very top category in this talk, which is my dissertation research. But I'm happy to talk about any of these in the Q&A or afterwards. All right, so today, again, I'm going to mainly talk about advancing accessible technology for blind and visually impaired musicians. I'm going to talk about 3 phases of that research. I'm then going to talk about a couple additional projects, and those will then lead me to my future research agenda to pursue at CU. Okay, so I'll kind of start with the primary motivation of this work. So music is sound, but notations and interfaces are highly visual, making commercial tools often inaccessible. So in the left image, there's a picture of Finale, which is a music notation software that I used for many years. It's totally inaccessible if you're a screen reader user. So across my work, I built a tool called SoundCells on the right with blind musicians to utilize accessible text input and multimodal audio tactile output. And in my dissertation, I reported on the current landscape of music technology accessibility, and I inclusively designed and deployed new technologies for individual and group use. So there were kind of 3 main guiding research questions that I addressed in each of these 3 phases of work. So first, to what extent do existing music technologies enable BVI music makers to accomplish their creative goals? What do they currently use? What technical barriers exist? And what strategies do they currently use to overcome those barriers? The second question is, how can we design new music technology to motivate and engage blind and visually impaired people in creating original music? What accessibility implications arise as a technology is considered, evaluated, and modified across iterations? And in what distinct ways do BVI people use a technology that they had a hand in designing? And finally, how do BVI people use music technologies in an authentic collaborative context? So how do music makers who are diverse in skill and vision ability interact with and support each other while making music? And the part that really motivates me, what new music and performances result kind of from interactions between BVI people and new technologies. And this process is very iterative, so I've connected, design and usability to deployments. These things cycle. So to turn to methodology, there are a few really important considerations when conducting research with disabled people, or in this case, with blind and visually impaired musicians. There's often very small sample sizes. So across this work, there's fewer than 15 participants at any stage. There's also a huge diversity, even within that sample size. So there's pretty wide backgrounds and really big differences in vision ability and assistive technology preferences. And these things, totally affect how an individual might engage with a technology intervention. And finally, there's the possibility of researcher bias. I'm a sighted person. I use music tools, with vision. And so I have to be really careful in conducting this work that the problem that I think is important to solve is actually the real problem, and things that my actual users are experiencing. So I chose certain methods to maximize participation and validity across this research. So again, as mentioned, I used participatory design. So I engage blind people in all the work. I use design-based research, which is a methodology that essentially technologies are deployed, iterated, and evaluated in authentic learning environments. And the publications about these technologies really emphasize factors of that environment and what went into kind of the thinking between design iterations. I use mostly qualitative data. Again, it's a pretty small sample size. So a lot of interviews and thematic analysis and coding, but there's some quantitative data. So participants are writing music and writing code, and we have those artifacts that we can look at. Another really important consideration in working with people with disabilities is to work with common assistive technologies. So a goal of a lot of accessibility research is not to replace assistive technologies, but to determine how a given intervention fits within kind of the landscape of tools that your users are already using. So, in this space, a lot of people who are blind or visually impaired use screen readers, which speak or personify the contents of an application and can expose it to refreshable braille displays. There's a picture of a braille display on the screen connected to my MacBook. And also, assistive technologies don't just work, but must be considered throughout development. So I mentioned that finale example earlier. Here's a video of trying to access that music software with voice over Apple's screen reader.
Voiceover on system preferences. Accessibility window. Zoom. Display. Finale. Untitled window. Empty scroll area has keyboard focus. You are currently on a scroll.
Right. So if we can see the screen, we can see that there's a musical score with tons of notes and things going on. But if you use a screen reader, it's just empty. It's just an empty scroll area. There's no music there. This is always a tough part, is getting back. And finally, before I get into what I did, there's a good bit of prior work that motivates this research in human-computer interaction and accessibility work. There's already a lot known about how blind and visually impaired people use technology and best practices for designing accessible technologies, like the Web Content Accessibility Guidelines. And in the last few years, there's really been exciting research on accessibility of creative systems for blind and visually impaired people. So like design and photography and digital fabrication. There's a good bit of research in music education. So things on how blind and visually impaired people learn in a traditional music classroom. But there was very limited work when I was starting this research about how they use music software and music technology. And finally, in the music technology world, there are a number of non-visual musical interfaces, especially interfaces that are tangible or use haptics. But in this kind of landscape study, the author, who looked at a lot of accessible digital musical instruments, reported that relatively little had been done for people with visual impairment. So the sort of gap that I was addressing was that little is known about how blind and visually impaired music makers learn to create new music with technology. And again, as a composer, as somebody who uses a lot of music tech in my own practice, making these systems accessible was something that I was really passionate and excited about. And for others in the room, pursuing a dissertation, this was something I thought that I could do for a few years and not get tired of it. All right, so I'm now going to turn to formative research, which was mainly revolved around an interview study that I conducted. So to better understand how music technology was accessed non-visually, I conducted 11 semi-structured interviews with artists that range in age, vision impairment, and musical style. To be included in the study, each participant shared with me at least one piece of original music. And in this population, all the musicians were pretty experienced, and they were thus kind of a bit older. 8 were over 50. And before I began, I realized that there was not one way that music gets made, right? But there are these common processes that a music education researcher describes under the categories composing, producing, and songwriting. And because each of these processes have technology implications, I classified participants based on early interview responses and asked specific follow-up questions to help locate when and where music technology interactions became inaccessible. And some, of course, have multiple practices, which is why the numbers sort of don't quite add up. But the kind of most important thing to know is that composers make musical scores for musicians to perform. So their medium is music notation. Producers make audio files for listeners to stream, download, or share. So they're really working directly with sound and with audio. And songwriters kind of do whatever, but basically they may not use any notation or any software. They may just play an instrument and sing. So to analyze the data from these interviews, I conducted a thematic analysis. I identified design implications resulting from music practice, medium, and vision ability. And last year, I actually returned back to this data set to focus on a kind of different part of the interviews, which was not just how do people make music, but how do they access notation, like if they are in a music classroom or they're performing on an instrument. I won't say so much about that study, but that influences some of my future work. All right, so some findings. So most participants described idiosyncratic setups with commercial and custom hardware and software. Most also used these third-party scripts developed by companies or community members to add screen reader support or to augment base accessibility features. And my paper from Assets in 2020 lists numerous accessibility barriers, both distinct to and common across practices. And I'll mention a couple here. So composers become dependent on sighted aid near the very end of preparing a score. And this is a consequence of common software designs called What You See Is What You Get, or WYSIWYG, in which basically in music software you can add notes and symbols, you can add things, but they often get added to the wrong place. And so they need manual positioning and correcting. And to do this, you need drag and drop in these interfaces. So in this image, this shows what can happen when you just stick the symbols in with a set of keyboard commands, but they don't necessarily end up in a good place. Producers, on the other hand, indicated that digital audio interfaces are difficult to navigate without vision. For example, one participant described how like a super simple task, like just checking the time when you're listening back to a song, like the time of it, it might take him 3 to 7 seconds to navigate up to that part of the interface where his screen reader will tell him the time. And navigating really long lists of information is also common and time consuming. So in this picture, using a screen reader to navigate a MIDI region, which is a list of musical events, is like reading a paragraph letter by letter. So just like this small chunk of a track has 994 MIDI events or notes, and that might just be one instrument or one part of an instrument. So, at the culmination of that study, I listed some design requirements to, determine some future research directions, in particular, input and navigation. So it's important to design simple, extensible, ability-based interfaces, and also to, if possible, embed musical hierarchy information. So again, being able to jump from like a verse to another verse, as opposed to going note by note by note by note. But to be able to do that, you need to have some understanding of the structure of a piece of music, or the user would have to kind of put that in. Additionally, supporting multimodal output. So, what's common across those things is that they rely a lot on the visual modality, being able to see it. And so, supporting other modalities But also an interesting music challenge is that music is sound, but a screen reader is also conveying elements with sound. So you have to be careful not to totally overload just the audio channel with both music and information. And again, to use inclusive design practices to focus on a specific group. But a neat benefit in this design space in music is that there are now these kind of universal protocols. So if your software can export a file in music XML or in MIDI, then any other music software will support it. So you can basically build like a very specific interface, but then they can collaborate with other musicians. Additionally, I mentioned this at the beginning, to supplement my interviews, I formed this really long-term partnership with a community music school in late 2019. So FMDG Music School teaches Western music, braille notation. It also runs ensembles, and it teaches music production to blind and visually impaired learners of all skill levels and ages. So there's 6-year-olds who, they have a top level of age range, but it's very young kids to older adults. When I approached the school, I asked, are there any opportunities to volunteer? And they basically were like, yeah, we'd love to have you involved. And we think it makes sense for you to have a title so that there's a reason why you're sitting in classrooms and people are sort of comfortable with you being there. So they gave me this title, Accessible Music Technology Fellow. And as part of that, over the last few years, I do a lot of work for the school, alongside these research projects that I'm going to report. So I teach lessons, I transcribe music. So I actually produce a lot of the music that students read by manually copying print and converting it to braille. We're creating a digital library of all of the accessible scores that they've accumulated over the years. I help with performances like playing melodica and field trips. I get to sit on classes. And another benefit of this kind of partnership is all of that extra time outside of classes, right? So I get to sit with families and talk with kids about other things that are going on. And this model of engagement with a community partner is, something that I will do beyond this collaboration, and that my future students, I would like to facilitate and mentor as well. And these two pictures on the screen are a couple of recent performances in New York City. There's a djembe. I think that's a djembe in that photo. All right, I'm next going to turn to the design phase. So this project SoundCells that I mentioned. So again, to return to those findings and design requirements a couple slides ago, I learned in my research that a lot of music software is designed around visual drag and drop input, which is not super accessible. And a few participants discussed these alternatives, these text-based languages, where you can basically write musical notes with symbols and text. So think LaTeX, but for music as opposed to documents. And while these tools were accessible to screen readers, the participants felt like the existing languages and editing environments were really complicated and meant for experts, and also really visual, right? So if you're writing LaTeX and overleaf, you're checking the PDF output, and the same thing is true with these tools as well. So I felt like there was a huge opportunity to explore a text-based music notation environment. And a further benefit of text is that it enables a separation of content and presentation, allowing for outputs in any modality, right? So to give another parallel, if you're building a web page, you can put down all of your content in HTML long before you're actually thinking about like, how will that web page appear and doing the CSS coding. So content separated from, style. In other words, to show this, what I was hoping for visually, a human readable text representation of music would get converted into like a standard encoding like music XML. And then from there, we could generate and customize music across modalities, including braille music, which is shown on the top, print music, and also we can play it back as audio. So I first built an MVP, or minimum viable product, to test out this idea. It leverages a bunch of pre-existing tools. The input language is an existing notation called ABC that I chose instead of inventing a new syntax, in part because there are already a lot of online databases that store music notation in ABC. So a tool that could leverage that and convert it to braille would very quickly make a lot of music accessible. It also uses CodeMirror 6 as the web coding environment. There are a lot of accessibility barriers in IDEs and web-based coding environments, and CodeMirror 6 is designed to address some of these. But as this research has shown, it's not perfect. And so we've actually identified a bunch of screen reader accessibility issues that we've reported to the CodeMirror developers. And we're still finding weird things. And again, this tool supports print and braille and audio output, leveraging a music theory library called Music 21 and web audio. And at the very beginning, after building this MVP, I conducted a design probe with 2 expert colleagues at FMDG Music School. So I put it in front of them, I had them write some music with it. We had kind of a discussion, and that validated validated that concept was usable and interesting, and also opened up some new design possibilities and challenges. So following the design probe, I invited them to collaborate in building the next version of SoundCell. So we did this over a summer. We met 4 times over the course of a couple months, where we figured out the layout, the keyboard commands that they would use, and the types of audio feedback built into the interface. And one thing that came out of those meetings were really more the expert requirements, because these 2 people had written a ton of music. One actually was pretty familiar with code. And so, they picked up ABC notation really fast and had an expert perspective, but they didn't really have a novice perspective. So following that set of design meetings, I ran a usability study with 5 students and teachers at the school. So in that group, all were voiceover users, 4 of whom had very little or no prior music technology experience, and all were able to notate a recognizable tune, and generally gave positive feedback about the interface. I'm going to show a demo in a second, and they especially appreciated this one feature about playing music back as it's typed. And this is the benefit of working with different kinds of user groups. They had a lot more difficulties with ABC text, even in this initial session, than the experts. All right, so I'm going to play this demo.
SoundCells is a music notation software available for free in browsers. It uses a syntax called ABC to input notes and other musical symbols, and renders scores in both print and braille notation in real time. The entire page is keyboard navigable and designed to be used with a screen reader. The main interface consists of a text editor, button to display the score and braille music notation, audio playback controls, and a visual rendering of the score. On the left is a bunch of documentation to get started, including a tutorial, and some example excerpts like the Mario theme you can listen to and remix. Currently, I've begun a score, named it A Nice Tune, set its meter to 4/4, and its key to B flat. I've also filled in 2 measures of music. By pressing Command-Shift-Space, we can hear them played back. Great. Let's complete this tune by adding a couple more notes and bar lines. Each of the letters I just typed, G, F, G, A, were notes. SoundCells played each one right as I typed them. Let's add our last note and a double bar line. Okay, I think I've finished this phrase, but I see a yellow underline below the fourth measure, so it looks like something is wrong. If I hover over the measure, it tells me it's underfilled, meaning it's not long enough. I can also press Command-Shift-M to open a diagnostics list that can be navigated with a keyboard. I'll fix this by adding a quarter note rest to the end. Okay, let's play the whole thing back. Sounds good. By pressing Command-Shift-9, I can display the Braille music. While focused with an external Braille display connected, a user can navigate the Braille music score line by line. There's also a settings menu where I can change some properties of the music. For example, if we wanted to make a large print version of the score, we might increase the size of the notation and also change the paper orientation and size to be landscape and 11 by 17 or A3. Finally, when we're ready, we can download the score. SoundCells supports a few different file types. An ABC text file can be easily shared, for example, copied into a body of an email. A Braille file can be embossed, a PDF can be printed, and a music XML file can be opened in virtually any other music notation software, meaning projects started in SoundCells can be continued in other commercial tools. So I'll click download, and I'll drag into view our new print score, a nice tune.
There we go. All right, so now I'm going to turn to the last phase of this work, the deployment phase. So at that point, SoundCells had only been used in short sessions, but not an authentic music making environment. So I organized a longitudinal study around a 6-week course taught remotely via Zoom and offered through FMDG School. The first 4 weeks of the course covered ABC text, while the last 2 built to a final performance with a professional musician, performing everyone's original works. Participants worked independently on weekly challenges and shared their music notation on a public website. And I interviewed each participant 3 times across the study, so around the beginning, the middle, and after the final concert. And my 6 participants in the study were very diverse in vision ability, skill level, and assistive technology preferences. 5 identify as blind, while 1 identifies as having low vision. 4 identified as female, while 2 as male. And again, they used a mix of assistive technologies with SoundCells, including a screen reader by itself, a screen reader with a Braille display, magnification, and 1 user actually used a Braille display alone with audio disabled almost all of the time. And I felt like this remote study design reduced barriers to join and worked well for facilitating high commitment asynchronous activities. Participants worked on their own and brought it into interviews rather than me asking for them to be creative on the spot during the interview, or in essence, writing code in front of me. And I saw high engagement, I think because participants were given opportunities for self-expression and a clear goal with a final performance that felt authentic, but wasn't too high stakes. And participants discussed challenging themselves. So for example, on the screen, I'm showing an excerpt of P1's composition, who was one of the more experts in the group. On the left side, it's in large print and standard print. And then on the right, it's hard to photograph Braille, but it's in Braille. And this piece I like to share because if anyone in the room is a music reader, you can see that that meter is pretty wild, 5/2. And this was actually so complex that that measure, so in Braille music, you'll have a line of 40 cells across. Some of those measures could not fit in 40 cells. And so, you know, our code basically wasn't ready to be able to break that across lines. So that required a quick patch just to get his score to the boss at the end. So yeah. So I wanted to highlight a couple final compositions. One participant, our youngest participant in high school, not only was SoundCells the first music software she had ever used, she had never composed music before participating in this study. And I'll play back her short piece performed on saxophone, and on screen I'm showing her music notation in ABC, print, and braille. Sorry. Oh. I don't know what to do. One of the things that I like reflecting on with this piece is how some of our syntactic challenges actually led to musical possibilities, right? So, you know, kind of asked her, like, maybe you could explore some 16th notes, not just 8th notes. And one of the kind of challenge prompts was to incorporate additional symbols. So she fit those staccatos in at the very end. So it's pretty nice. And reflecting on this piece, she said, I was like, that sounds really good, but wow, I didn't give it time to breathe. Right? There's no rests. So that doesn't matter if you're playing piano, but if you're playing saxophone, you have to breathe. And so that was kind of a learning experience too, just having a human performer. So not only, you know, does she continue using SoundCells, she shared it with a friend. I maybe won't play this piece in the interest of time, but another participant was an instructor who teaches Braille music and piano, but has very little music software experience. This is common at the school, but she predominantly uses a Perkins Brailler for teaching, which is like a typewriter. And she treated this experience a little bit differently, in that in each week, she kind of continuously added to this piece. And an expert requirement that she shared with us, you've probably noticed in these scores, a limitation of SoundCells right now is that it only supports single voice instruments. But for her as a piano teacher, she needs to be able to write scores with a left hand and a right hand part. And so that's kind of a future challenge. You know, and just looking at this, even if I don't play it, to risk getting that, oh, the button's on a different part, I'll play a little bit. Continues. It's really nice. That piece is formally much more sophisticated. And one of the nice discoveries in the interviews was a lot of the participants commented on how each piece reflected individual skill level and aesthetics, and that's really clear. Oh, and all of those actually were screenshots from a public website, so you can kind of scroll through and see their pieces. So I'll share some findings. So while SoundCells supported all these different workflows and assistive technologies, there were plenty of usability challenges. And I'll turn to the text input part first. So many noted that the process of inputting notes was sluggish and unintuitive and required really careful thought. Right, so on a piano, the notes are organized by frequency. So from left to right, the sound gets higher. And a C major scale, you just play the white keys from left to right. But anyone in the, the people on the room on computers, if you try to kind of hunt for the C major scale, C, D, E, F, G, A, B, they're all over the place. So that mapping doesn't totally line up. And other really important characters are all over the keyboard and need shift held sometimes. So that was pretty slow, especially for people used to playing piano. Additionally, and this factors into this little teaching talk tomorrow, ABC notation uses fractions for rhythms. And these fractions have to add up to 4 for a 4-4 common time measure to be complete. So this becomes really difficult, really fast, especially for screen reader users, right? So who might have 8 or 12 fractions read at them in a short period and have to add up in their heads. Does that add up to 4, right? Do I have enough thirds to equal enough triplets? So a lot to keep track of. And finally, participants expressed confusion about the design of ABC syntax and the choice of certain characters. So one said octave down, octave up is comma, apostrophe. What's the relationship between those keys? And as this image shows, if you can see this notation, that relationship is apparent. The spatial positioning of these characters reflects their behavior rather than the symbols themselves, right? Apostrophes are located high next to letters where commas and underscores are located low. But of course, right, that does not come across in Braille, and that does not come across when read out loud. And in terms of output, while SoundCells supported really flexible use styles, participants identified challenges navigating across modalities. A common workflow discussed was that one would hear a mistake, then find it in the Braille or large print score, and then need to find it and correct it again in the ABC text, and then listen again to verify the fix. And so each of these modalities could require some navigation. And finally, screen reader users pointed out that their text is not read as they interpret it. So for example, underscore F, comma, comma can be interpreted as F flat 2 quarter notes. P4 said in a regular Word document, if you wrote, I went to the store and I bought apples, bananas, clementines, it would say that. So it would be helpful if it actually read A eighth note, A dotted quarter, bar line, that kind of thing. So just to summarize some of the research contributions from this work over the last few years, this involved a partnership with a community music school, an interview study that resulted in 2 publications, a new technology, SoundCells, an assets poster, and a Web for All paper, and a composition class in performance that resulted in a very recent assets paper. So this research into how blind and visually impaired musicians leverage and adapt music technology has been cited by other researchers studying creativity and accessibility. It was super exciting at Assets, the Conference on Computers and Accessibility, to meet 2 younger doctoral students who are doing this exact topic and cite that 2020 Assets study as some of that foundational work. It resulted in SoundCells, an accessible free browser tool, a free course for students to compose music, and a final contribution that I'm really proud of was that over the past few years of this work, I led an undergraduate applied research course in which students learned about accessibility and design for credit. The first SoundCells prototype was largely built by undergrads that I mentored. And most of the co-authors on those publications are undergrads and first-time authors. And Fabiha, a student who worked with me for 3 years, actually presented her part of the work at the NYU Tannen School of Engineering Expo and won an award. And this is a picture of her with the Dean of Engineering at NYU. All right, so in my last sort of chunk of time of this talk, I'm going to briefly highlight a couple other projects and then share some ideas for future work. And that's going to touch on these 2 areas. All right, so first is FiLOrk, which builds on a lot of the SoundCells findings. And FiLOrk stands for the Fil Laptop Orchestra. And this is really transitioning a little bit away from music education to also computer science education, and using this practice called live coding or algorave as an accessible CS education method. So similarly, this has been involving the development of a new tool called text management. I've been co-designing this with a local New York City musician and live coder. And we've been teaching a live coding class for 5 high school students at FMDG Music School. And in December, they performed for the first time. So I'm going to play just a super short kind of piece on that.
We coordinated it such that we would all start gradually in a certain order and then gradually add more and more effects to our patterns. So by the end, they were sounding pretty mangled, as you can hear. And then we also engineered a fade out in reverse order, kind of taking it full circle.
Let's take a stab. And on the table are some tactile graphics and braille and large print materials that we made. And another project that I've been working on, again, using very similar methods, is called Danceon, which stands for Dance Object Notation, which was designed in partnership with a New York City organization called STEM from Dance. And it was really intended to be culturally relevant and really meaningfully involve body movement in code and dance. And Danceon was designed during COVID, so we had this real constraint for putting on a summer camp that all the students would be remote, but still wanted to have a group performance at the end. And since then, even in person, Danceon's been used by more than 50 young women in after-school programs in New York City. Unlike the other 2 projects, Danceon is actually involved designing our own domain-specific programming language. And it basically, it's declarative and it uses this kind of human-readable syntax. So describing what, where, when, and how animations will appear based on your body position. And again, I'm just going to play a super short excerpt of this. I'm happy to answer any questions about that performance in Danceon. But what's super exciting to me about this work is that there's so many different layers. So they thought about their choreography, they thought about the colors, they thought about the meaning of the song, the transitions in the song. They thought about the clothing that they were wearing. So it's really, really fun. All right, so really quickly to conclude this talk, I'll identify a few areas of future work that build on each of these prior projects. So the first area is broadening access to music notation for blind and visually impaired people. For the most part, music that's sold by publishers or available for checkout at libraries is only available in a PDF format, meaning it's inaccessible. And currently there are these small teams like the one that I work with at FMDG school that copy PDF scores and then use conversion software and a bunch of editing and proofreading to make accessible music. But this is super time consuming. And as a result, there are these really small collections of accessible notation distributed around the world, but it's really hard to find like a particular piece that you're looking for. But as my work with SoundCells demonstrates, like it doesn't have to be this way. It's pretty easy to convert across modalities if you have access to good source files. So my goal is to increase the amount of high quality braille and large print music notation available to blind and visually impaired musicians. I aim to explore crowdsourced volunteer work and score scanning for converting across formats. It'll also be really important to determine the best way of storing music notation, providing access to it and being able to customize it. And I think that this work can have broader repercussions beyond accessibility to music learning and memorization. Thinking about music not just as this locked image, but as something that's customizable. A second area of future research is creative learning with artificial intelligence. And there's a lot of really cool work at CU happening in this space. So Danceon is an early computing education system that integrates AI, and pose detection is at the center of Danceon. And it's not perfect. So in these images on the screen are a couple examples of the pose detection breaking down. So a sleeve being, guessed as an arm, and one of my favorites, a body on a t-shirt being predicted to be an actual human body. And in the context of the educational work that my team was doing, we chose to view this as learning opportunities of thinking, what are the edge cases? What are the limitations of AI? And then using that to connect with other AI systems that they're familiar with. And of course, it's on everyone's minds, like generative systems like ChatGPT and DALL-E are only going to become more prevalent in education and creative professions. So it's important that we start working now with educators and artists to ensure that these systems are used responsibly. So again, quickly, my agenda is to explore how AI systems can be incorporated into high school education and how they can complement human creativity. And part of teaching with AI also means to recognize biases and limitations in outputs, right? ChatGPT is not sentient, but essentially is souped up autocomplete. Oh, and another quick point is that this is actually work that's currently being done with CU collaborators in dance and in education. And finally, my final area of research to explore is collaborative live coding as a model for inclusive computer science education. So FiLOrk's continuing in the spring. They're exploring new programming techniques and strategies for manipulating sound. And we have performances scheduled at the Met Museum and the Andrew High School Library, which is a public library in New York that supports braille and large print materials. So I aim to study creative collaboration practices of blind and visually impaired youth in person and in remote environments, and also to improve code and text editing systems. And again, I think that this work has broader implications in accessible learning and software development environments. All right, so thank you all. I'll stop there. There's a few minutes and I think there's a session right after this. So, yeah.
Love it. I have a ton of questions, but I'll keep it to something framed. You mentioned that many composers struggle with navigating their work and the potential of having like a hierarchy of the music like we do with headers and our screen readers. is that something that's available in SoundCells, or is that future work that you're intending to explore?
Yeah, that's a really good question. That's still future work. There's some, I actually think HTML is a good example of this, where you can create really well labeled documents, right? So H1, you have to do it manually, but like H1, H2, H3, and so you can create that structure. And then if you do that in the website, it's really easy to navigate with a screen reader. So ABC notation doesn't have that syntax to describe, hierarchies manually. One kind of immediate thing that we want to do is just be able to jump across measures. So you can at least kind of go at the word level as opposed to the character level. But yeah, work around kind of automatically analyzing a score or providing users the ability to sort of label aspects of the score is something I want to work on in the future. Yeah. I saw your hand first.
Yeah, so I'm just curious about SoundCells. As you do like future development on it, are you planning on possibly making it a plugin for already existing programs like MuseScore, Finale, or do you think it's best limited as its own SoundCells?
Yeah, MuseScore is a great example, actually. MuseScore 4 was just released with a ton of accessibility settings. I think the difference, I don't know the answer to that quite yet. I think the biggest difference is that MuseScore, again, is a visual interface that has accessibility features built into it, whereas SoundCells has kind of an opposite sort of framework where it's like a text interface that can create things in different modalities. I think the way that I'm leaning towards future work around SoundCells too is like, how can we build in libraries of accessible music notation and ABC notation? So not necessarily integrating it with additional tools. I mean, a cool feature would be like an open and MuseScore button. So you could start a score in SoundCells and then continue it in something else. But yeah, I think a plugin would be a little tricky. Yeah.
There was one of the limitation was that the input, like putting the input to your sound set was slow and
Yeah.
also it was really complex. Were there any other options, like other methodologies, right, like speech to text, like where the composer would say the notes like how you said some what note, and the sound set would start putting the ABC. So that would reduce the.
Yeah, that's also part. The low-hanging fruit is to add some MIDI controller input support. So you can play, I mean, that gets a little bit strange because you're sort of typing on a piano key and then that would then type the text. But yeah, one of the sort of visions of this type of work is like multiple ways to engage. So right now it's like single input, multiple outputs, but the future direction would be like multiple inputs, multiple outputs. I think the fun challenge with speech to text is what is the user saying and how does that get translated into the ABC code? So another thing too to say is there's kind of a history of this that in this community that we would want to draw on. So there was work where it would be a sighted person and a blind person collaboratively producing a Braille music score. So the sighted person would look at the PDF, have kind of a shorthand way of speaking the notes, and then the blind person who could read Braille music would emboss it. And there are things about ABC that are sort of specific based on the headers. So for example, if you're in the key of B flat and then you type a B, it's a B flat because you're in the key of B flat. So the kind of speech to text input would be like the user would read the notes, but the resulting text may not always be the same, given some of that context. So it would be a fun problem, I think.
Maybe we can.
Yeah,
any questions for this?
Yeah, I just have one in chat. So how does SoundCell account for design challenges in cross-modal navigation, since screen readers are working at the same time while BBL users are correcting the ABC notation based on the mistake heard in sound? leading to overloading and interference by different audio output. Doing this would cause more interference when there are more instruments involved. And I believe Hunar, you're still online, so if we need clarification, feel free to unmute.
Yeah, I mean, the part of how I'm understanding that question actually gets back to what I was mentioning at the beginning a little bit, which is being overloaded by multiple channels. So SoundCells, that's exactly right. That demo did not have a screen reader turned on, right? But when you type with a screen reader, it reads the characters back to you. So one way that currently addresses it is there's an option in SoundCells to have a time lag. So basically it will read the text back to you and then play the pitch of the note after it's been read. Most people it was interesting, like that need came up in co-design, but in the actual study, most people just kept the two events happening simultaneously. So it would speak the text and it would play the pitch in parallel. And that seemed to work. But yeah, I mean, the biggest challenge, and I don't totally know how to do this with web browsers where you have a little bit less control over the accessibility API, is getting it to read that text back to you in a way that you understand. Again, when you type words, it will read the word back to you, but it will just read kind of gibberish sometimes with ABC. Yeah.
Okay, I think next time Billy again, and we'll be here for next half an hour in case you have any other questions.